So in 7.4, we're going to look at fractional exponents. Now I want to show you first what these mean, because really these fractional exponents are really just radicals, square roots, cube roots, that kind of thing. So let me show you the pattern here. Your base, the 125, is what goes inside your radical. Your denominator is your root, and your numerator is the exponent here. So we're really just talking about cubed root of 125. And since 5 times 5 times 5 is 125, cubed root of 125 is 5. Now when you're dealing with a fractional exponent, you've got a couple of options. You can leave it in this form, or you can change it over into radical form, whichever one's easier. In this case, I'm going to change mine over. Square root of 5 times square root of 5. Oops, I did not mean to put a 5 right there. Square root of 5. Square root of 25, which is 5. So one option is to change it over. I'm going to do the same thing here. So here I've got cubed root of 10 times cubed root of 100, which is cubed root of 10 times 100, and 100 is 10 times 10. So I've got 3 tens. So again, your pattern for changing these over is the base goes inside, denominator, top. Base goes inside, denominator, numerator. Okay, now I want us to just look at a few little simplifying things and a few little kind of opposite order things. So first of all, if you've got a negative exponent, remember that means that your stuff goes in the bottom of a fraction. Now let me see if I can simplify this. So this is square root of y to the 5th. And I can simplify that down a little bit, because if I have 5 y's, I can pull 2 of them out. That would take up 4 of my y's, square root of y. Now that's great, but I'm not really supposed to have a square root in the denominator, so let me rationalize that thing. So I have square root of y over y to the 3rd, because this right here is a y, and I've got 2 there, so I have 3 total. Okay, now if I give it to you in radical form, you can change it to the other form. So x to the 2/3. Remember, if it's square root, it's like an understood 2. So y to the 3/2. Now I think you could simplify that, but I just wanted you to see how to change forms. Okay, so I'm giving you this as a fraction exponent. I'm going to try to change it to square root of all that stuff to the 1st power. And then I can simplify this. Square root of 16 is 4. Square root of 81 is 9. Square root of x to the 14th, remember this is square root, so is x to the 7th, and y to the 9th. So depending on the problem, some forms may be easier than another. Now I just want to remind you of your exponent rules. We use these a little bit, but I just want you to have this in your head. Now this applies to the fraction ones as well. So if you're multiplying, you add the exponents. If you're raising to a power, you multiply the exponents. You're dividing, you subtract. So it's x to the 1st or just x. If it's a negative exponent, you put it in the bottom of a fraction. Now here, I just used regular exponents. All of these rules are true for the fraction exponents as well. So for example, if I have 32 to the 1/5 raised to the 5th power, I would multiply those together, which would just give me 1. So I'd have 32 to the 1st power, which is just 32. if I have this, I could go through and get a common denominator. So 1/2 is 3 over 6. 1/3 is 2 over 6. Oops, that's a 6. Which means total I have 5 over 6. Now this is great. Depending on what I asked you to do, you could change it over to this form. So just depending on what the question was and what form they asked you to put it in. Now, what I want you to get in the habit of doing is thinking about, is it going to be better to change this to a radical or should I leave it? Now, for me, I think like this one, changing it to a radical is easier because I can take the 4th root of 1 and I can take the 4th root of 16, because 16 is 4 2's. So changing it to this form was helpful for me. Whereas looking at this one, I don't really think changing it to radical form would be helpful. I think I just need to subtract those exponents. Now I can do that. So 7 over 4 minus 2 over 3, so I'd better get a common denominator. So 21 I'm going to multiply by 3, and here I'm going to multiply by 7. So I'll get negative 2. Okay, so this is x to the negative 2 over 21. So I'm going to do two things. First of all, I'm going to put that in the bottom of the fraction to take care of the negative exponent. And then I'm going to go ahead and change it over. Now, on this one only, we're not going to worry about rationalizing because I gave you one that's messier than I would ask you to rationalize. So we're going to leave it this way. Typically, you would rationalize. Okay, and then here's one that's kind of, you know, you could do it probably either way. I'm going to leave it in this form. So I'm going to do 2 to the 3rd is 8. 2 times 2 times 2. And I'm going to multiply these together. So 3/4. Now that's great. I'm just going to change over to the other form. And the last one we're going to look at, this is all raised to the 1/2 power. I'm going to change it over into a square root. So this is like a 2. And then I'll take the square root of each of these. So square root of 9 is 3. Square root of x to the 4th is x squared. Square root of negative y to the negative 2 is negative 1. And then I should probably put that in the bottom to take care of it. All right, fraction exponents can be a little tricky because you do have to deal with fractions, which I know some of y'all don't like. So just make sure that you're thinking when you do the homework on this section. All right, so that was 7.4.